Hello, welcome to Sweden Innovation Day, the day 3 of this global digital event with a focus of international collaboration towards UN's global goals. Thank you for making space in the agenda for RISE. We will give you a flavor of the test and demo facilities. So I am Karin Johnson. I'm the CEO of RISE Processum, and I will give you a flavor of the test and demo facilities. And with me, I have Claes Engström, the program manager of the brand new test and demo environment being built. I have Björn Alriksson, head of biotechnology at RISE Processum. I have David Blomberg Saiten, research and business developer at RISE Biorefinery and Energy. And I have Johan Börjesson, head of innovation systems at RISE Processum. RISE is an independent state-owned research institute and innovation partners for every part of society. We help develop technologies, projects, services, and processes that contribute to a sustainable society and a competitive business community. We do this in collaboration with academia, the public sector, companies, and sometimes on behalf of companies. And we also have a special focus on helping SMEs in their innovation process. RISE is a non-profit research institute focusing on industrial challenges for transition to fossil-free society. We promote innovation and competitiveness in industry, accelerate innovation and drive sustainable development through co-creation collaborations with cross-disciplinary research and innovation. A few numbers lets us know that RISE is one of the 5 largest institutes in Europe with our 3,000 employees and 130 test beds spread all over Sweden. Gender equality is important to us, and we believe that enhances our research, and we're heading towards climate neutrality in 2025. The test beds and then demo environments, testing and verifying is fundamental to developing new and existing products, services, and innovations. And this is an opportunity that RISE creates with approximately these 130 test and demo facilities on a number of different areas. Independent open access test and demo can accelerate development for both private and public actors, and RISE test and demo facilities are available to all types of companies and organizations in different stages of development. Test and demo facility is a place where you can come and test and verify future solutions. A test plant must be developed in line with what's going to be tested within it. And when the business community pops the question, the facilities need to be there ready to tackle the issues. Therefore, I believe that the continuous dialogue between the test and demo facilities owners and the actors that have the interest in them is very, very important. The test and demo on today's table is about bioeconomy infrastructure and the build-up of a new refinery capacity. The existing distributed infrastructure that we have is the foundation in this investment program. And we have a distributed infrastructure from north to south of Sweden with slurry hydrocracking, gasification pyrolysis in the north, further south, biomass fractionation, biochemical and chemical processing. Further south, anaerobic digestions. In the capital, we have paper making, pulping, lignin and cellulose valorization. Södertälje, we have chemical processing, Bäckhammar, upscaling of lignin and separation and production. Further south, gasification, pyrolysis, biocomposites. All these infrastructures have contributed to our biorefinery initiative, And we are investing in several different places to upgrade infrastructure and also building a complete new center, landing in the middle of Sweden in Örnsköldsvik, which I will ask then the next speaker, Claes Engström, to tell us all about. So with that, welcome Claes, and I shall take this down to allow you to share your slides.
Thank you very much, Karin. I will talk a little about the investment that we are doing in the biorefinery pilot plant within RISE in Sweden. And this is an assignment from the Swedish government that we got a year ago. The purpose of this whole endeavor is actually to try to improve conditions for commercialization of new products and solutions. So what we are aiming for here is to go up in scale and to be able to test some of the new materials, some of the new fuels, etc., in a more product scale, so we can actually do product tests with this equipment. It's a part of the climate action in the Swedish budget proposals, so we are aiming for rather bigger solutions that can help the climate rather than small-scale solutions. So we would like to go rather high in volume in terms of these products that we are aiming to create together with industry. And we are also looking to establish a world-class center to be able to attract industry researchers and entrepreneurs, not only from Sweden and Europe, but from the whole world. There are a couple of major components to the investment. We are building an open, flexible pilot hall dedicated to various test beds and biorefinery development. I will come back to that, how it looks. And it will be placed at the existing RISE operation in Örnsköldsvik. And this is, we have about slightly less than 100 people working in biorefinery in Örnsköldsvik today, and we hope to improve these numbers when we get these important facilities.
Claes?
Yes.
I have to ask you to start your presentation again. We don't see. I suspect you have changed slide, but we don't see.
Okay, thank you. Sorry about that. To repeat then, we are actually doing three things here. We are building a new pilot facility and an innovation hub in Örnsköldsvik, where we will be able to meet the needs of businesses and researchers from all over the world. We are also upgrading and developing a lot of the existing biorefinery infrastructure that Karin mentioned before, and improving both in scale and in function. And we are putting a lot of effort into creating not just hardware and equipment, but also to create a really innovative place where innovators, researchers, and entrepreneurs can meet. So these are the sort of major components of the project. And after quite a thorough and intensive spring last year, we have chosen a number of technologies that we will be investing in. And these are the 6 major parts. First of all, we go into a big strategic investments in biotechnology, where we are aiming to build both in terms of scale up, going from really small scale up situation to being able to produce on a 10 cubic meter scale in terms of biotechnology reactors, and thereby be able to test a lot of new products. We are also aiming for a high throughput mechanism and equipment that Björn will talk a little more about, which will improve speed to get to the market. I will not go further into detail on that. And another big part of these investments will aim to do carbon capture and storage, as well as carbon capture and usage. So we are going heavily into electrochemistry and into carbon capture technologies to build pilots around these as well. Other than that, we are improving on capabilities that we already have and are quite strong at RISE, like chemical conversion, lignin to fuel and chemistry, lignin to material, and cellulose in new packaging solutions. So these are the major components of the investment projects, and this is pretty much completing the existing park at RISE. So now we feel that after these investments, we have many of the major steps of the biorefinery, and we will be able to imitate an entire biorefinery and help the customers, not just looking at the main product when they do their development, but we can go into a number of the residual streams that has to be dealt with in order to create a really competitive factory or mill. This is how it will look like. It will be built in Nordic spruce. So we will have a connection to what we are doing in terms of the architecture. And it will be connected to the already existing buildings at Moore and Rice Processum. And this is a scale of the different pilots where you have the biotechnology to the left, the chemistry to the right. And then we also have areas at the bottom there who are meeting venues and offices. And between these two, we also build up a specific area for customers so that companies can come in with a specific test beds to try specific biorefinery technologies where we can run them on account of the customer and make the analysis work and connect them to the utilities necessary, like high pressure steam, different gases, and so on and so forth. And the time frame for this is that we are hoping to have a pilot hall ready at the end of this year. So it's a very intense year that we are having in front of us. We are starting the discussions with the builders right at this moment, and we hope to start digging in April. And we are hoping to finish the entire product in the middle of 2023 and be able to run all these 25 to 30 test beds in its entirety in June 2023. So hopefully this gives you some idea of what we are doing. So I will stop there. Thank you.
Okay, Claes, we have a question for you. So the question is, in what way do you foresee that these test beds will improve commercialization of bioeconomy projects?
What we are hoping to do is to be able to produce amount of raw material enough to be able to product test stuff. We will not be able maybe to process test the different processes thought out when they are in really large scale, but to be able to have enough material to actually make the products that can go on the market. And the other part is that we will have basically all the major technologies within RISE necessary in the biorefinery. So we will be able to imitate a large-scale biorefinery in terms of computer technology. So we will be able to simulate a new type of biorefinery for the customers, where we will have enough information to make useful simulation and techno-economical analysis on a future plant. That's the vision for the entire park.
Thank you, Claes. Hopefully that this will help future companies, future solutions to come to market. Then any more questions? No. Then we will welcome up Björn Alriksson, Head of Biotechnology at Rice Processum. So now I think I've shared the right screens.
Thank you, Karin. Yes, I'm Björn Alriksson, Head of the Biotechnology at Rice Processum. I will give you a taste of what we can offer within the exciting field of biotechnology. So our main focus is development of sustainable biorefinery processes and products. And we commonly work with feedstocks such as forestry residues, agricultural residues, and industrial residual streams. And we offer competencies within thermochemical pretreatment of biomass, enzymatic hydrolysis to produce sugars. We also do a lot of different process development on various fermentation processes. And we also offer expertise within strain development to be able to generate better, more efficient microorganisms and enzymes. So, of course, you can make a lot of cool products with biotechnology. I have listed a few of them to the right there in the list. These are products that we are developing at the moment. So it's everything from making single-cell proteins that can be used as animal feed, lactic acid that can be used for making bioplastics. We have ethanol that can be used as a biofuel or as a biochemical. Other interesting processes are, for example, bacterial nanocellulose, where we have a bacteria that we feed with sugars and produce a nice, unique polymer. Other products we have is fatty acid production with oleaginous yeast, enzymes and proteins, and other biochemicals. And the tools we have for this development is mainly lab scale equipment and pilot scale equipment. So here in Örnsköldsvik, where we are located, we have a very good set of infrastructure. We can go all the way from developing microorganism, do process optimization, and also do scale up. So as Claes briefly mentioned, we are building a high throughput strain development platform that, well, we will use it to make more efficient microorganisms and enzymes. And the capacity of this facility will be to be able to screen tens of thousands of different microorganisms at the same time. The best microbes we can take further for process development, process optimization at lab scale, can then go to mini pilot scale. And in the end, we can scale this up to 10,000 liter in our new biorefinery test bed lab that we will soon have. So that will also be a food grade laboratory, so we can do food grade up to 10,000 liter, including downstream processing. So an example on processes that we have been developing is the wood to food concept. So this is something that we have been developed for quite some years. And the idea here is to turn wood into food. And as we cannot consume wood directly, we go through the route of converting industrial residual streams that contain carbohydrates. We feed the carbohydrates to microorganisms that are rich in protein, and they create single-cell protein. And this single-cell protein we can use as a substitute for unsustainable protein sources such as soy protein or fish meal, and we can use it in fish feed. So the product here can be used in aquaculture to generate, well, fish, and the fish can, in the end, be on the plate. So we have taken this concept all the way from small lab scale to pilot scale and also to demonstration scale. So on the slide here, you can see some pictures from a demonstration scale experiment where we have taken a residual stream from a local pulp mill. We have grown a filamentous fungus, which is rich in protein. And you can see it down to the left there. It's a big white filter cake of fungal biomass. So we take that and dry it and grind it into a powder. And then we have performed fish trials on 3 different fish species where we have substituted soy and fish meal and replaced it with single-cell protein. And the results are, well, excellent. We have shown that the growth of the fishes are equally good or sometimes even a little bit better compared to when we feed them with a conventional fish feed based on soy or fish meal. So with that example, I think I will end my presentation and thank you for your attention. And if someone is interested in collaboration, don't hesitate to contact me and let's talk some more biotechnology. Thank you.
Okay. So Björn, a question has come in. And it seems, so I need to read it. So in what way is it possible to collaborate with you?
Well, we love collaboration, of course, and there are several different ways we can collaborate. We usually participate in large joint collaboration projects, research projects, so that's one way. Another way is also that we can work on a contract basis. If a customer comes to us with an idea, we can help them and just specifically work for them.
Thank you. So then we, any more questions? No? Then I was going to, I will invite up on the stage, the stage table. David Blomberg Saiton from RISE Biorefinery and Energy. He's going to tell us a little bit about the chemistry infrastructure.
Thank you. So, David Blomberg Saiton, and as Karin said, then I work at the Biorefinery and Energy department at RISE. I will give a brief outlook on the infrastructure for scaling up biorefinery process from the chemicals perspective. And I also claim here that infrastructure is one of the keys for successful innovation stories. So I will actually try to give a few examples on that as well. So first of all, the chemical biorefinery toolbox, it's a vast, there are a lot of different type of processes that we include in that one. Fractionation of biomass, flow chemistry, continuous processes, high pressure, high temperature chemistry, modification of cellulose, and also, as Claes already mentioned, electrochemistry is something that we are really scaling up right now. And of course, in the end, you also need this workup and purification as a really important part of the whole process. So what's the purpose really for building up this pilot scale infrastructure? Well, I pointed out a few things here. I started out with safety. And of course, safety is really important in the chemical biorefinery development. Are we doing something that is dangerous or not? So you find out that type of questions, you find out the answers, you find bottlenecks, and you identify specific challenges within the specific process that you're developing. And in the end also, in the process development, you are able to verify processes. One thing that also has already been mentioned, you have the possibility to produce a lot of material for applications tests. You really can test the products that you prepare in a real environment in the end. But maybe one thing that is, at least it's of great importance, to generate the basis for further scale up or for how to take the next steps towards a full-scale implementation. So on the following slides, I will give a couple of examples where we have been collaborating from RISE side with small companies to develop techniques entering the market in a full-scale plants. So the first challenge that I will describe is the sludge produced in Europe. So you see it's a 50 million ton sludge produced in Europe annually. And it has a high water content. It's really hard to dewater, low heating values. So the value of burning it is not very high. The cost for disposal of this sludge is increasing. And also sludge can contain pathogens. So actually on the picture to the right, you can see to the starting incoming sludge, it actually contains solid material and water. So is it possible then to divide the bioslide into these two components? And yes, in a collaboration then between a company called Seagreen and RISE, we built a pilot for based on ideas and trials done by Seagreen. This continuous pilot you see in the picture was built up in Örnsköldsvik and operated by both RISE and Sea Green. Learnings from these pilot trials actually set the base for further scale up, and eventually this was installed in full scale at the Stora Enso mill in Heinola in Finland. So here you can see in the gray on the photo to the right, you see the plant, the HTC plant, and the HTC carbon is used as a biofuel that reduces fossil carbon emissions up to 2,500 tons per year. Another company that has been collaborating, RISE have been collaborating, Cinis Fertilizer, and they use ash from the pulp and paper industry and turn it into a mineral fertilizer. So in this case, RISE and Cinis collaborated in process development, and I can also say that we have a good connection to the pulp and paper industry in the area. So all trials were performed on real ash samples from the pulp industry. And besides verifying the process concept, we also prepared a market analysis for potassium sulfate, and we also made a investment cost calculation for a full-scale plant. And at this stage now, the company Cinis Fertilizer has applied for an environmental permit for building up a full-scale plant in the north of Sweden. So with that, I say thank you for your attention. And I end with the same picture as Claes showed, and we think that this kind of work we will be able to accelerate this kind of work in the future with this new pilot hall that we are building up. So thank you.
Okay, question for you, David.
Oh.
Infrastructure is one key for innovation. What other keys do you see do you need for successful innovation?
Yeah, bringing an idea to the market is actually composed of a lot of different tasks. So I can say, for example, you need techno-economical evaluation, you need market analysis, you need life cycle assessments. You can also need, as we did together with Cinis Fertilizer, calculating investment costs and say how will everything look in the end. So there are a lot of components that has to be achieved before you can build something in full scale. But there we can, of course, have personnel at RISE that can help out in all these fields.
Absolutely. And the numbers added up for the Cinis Fertilizer then?
Yes, they did.
Brilliant. Thank you.
Super. Thanks.
Thank you, David. Then we shall see. We have, I shall stop sharing here. Then I can welcome up Johan Börjesson, Group Manager of the Innovation Systems Group at RISE plus SM. Welcome.
Thank you very much, Karin. So now that we've heard about this wonderful infrastructure, new infrastructure, we heard a lot of really good examples of the research that we do, some really good cases with the companies that we collaborated with. I wanted to kind of build on that and talk about what work we do to connect companies with each other, with the research institute that we work at, but also with all other parts of society that can support the development and scale up of bioeconomy innovations. So on the picture now, we see the site for the vibrant National Center for Bioeconomy Development in Örnsköldsvik in Sweden. And it's a beautiful area, and there's a lot of activity within biorefining that happens here. So so what do we do in order to help and facilitate that companies really find the right context, the right collaborations, and the right support structures to develop their ideas? Well, we do. We have a network, a large network around us, and a cluster of companies and universities and municipalities that we work with, and we can see in this picture the first layer of that innovation cluster with the classical triple helix of industry, academia, and society, and what we do at RISE Procession to work on this is that we identify, build, and then we accelerate processes for development and commercialization of bioeconomy innovations. And what can that really mean? So one example is that we have what we call the R&D Council, where we have a mechanism for companies to apply for projects together. We can help them with performing the research or finding the external resources to bring their ideas further on, and we also provide the finances for them to do that. So that's one example of what we do. But then we have a lot of other different ways of supporting companies. Another really important aspect is to strengthen the national innovation ecosystem, and that is really all about being connected with all the support mechanisms within society that can help a company grow, and a lot of that is about finding the right industry collaboration, finding the right research infrastructure, finding the money, finding the right financing, funding or financing. So that is another aspect of how we support the innovation. And a third aspect, which is really important, in this context where we are today, is international collaboration. And we work closely with the regional companies and try to help them build the complete value chains. And in order to do that, we need to reach out into the world and find the right raw materials, find the right markets, find the right technology providers, so that the complete value chain can be built. So that is essential for what we do at RISE Procession and in our work to support innovation. And the fourth point here is that we try to be an innovation partner through the entire kind of innovation value chain, all the way from idea to commissioning. We are there to provide the right expertise, either from the institute itself or from external sources. So I will move on from that. If I talk a little bit further on this international collaboration, there's a lot of innovation power within the small and medium enterprises, and a lot of what we do is to find those new technologies that are being developed and connect them with other small companies. But most cases there is a large industry that is looking to collaborate with them, and we at the industrial kind of site where we are at, there is an opportunity for industrial symbiosis where a small company can establish themselves. They can utilize the side streams from the pulp mills. They can utilize heat and energy and facilities. So there's this. What I want to emphasize there is really the opportunity to kind of seek us out and actually establish your company within our region. International collaboration is a lot also about participating in European projects, and I mentioned here Horizon 2020, where we during that framework program participated in 12 large projects, which means it's about 2 projects a year that we participated in. And we are heavily engaged in being part of Horizon Europe, which is the new framework. Contract research is also a way that we work to directly support a specific company to develop their ideas and use our research and research infrastructure. And within the last couple of years, we have collaborated with 220 companies in 21 different countries. So we're really reaching out. And this last slide, I wanted to kind of emphasize, where we are. We are at the High Coast region. We have a brand name for the industrial cluster where we are, which is called the High Coast Innovation Park. And in the picture to the far left here, to the bottom left, you can see kind of that logo is kind of overlain with the industrial site where we at. We are a highly connected region, and we have the partners around us to really help and facilitate a soft landing here for a company to establish themselves. One is High Coast Invest, where you can really find they are there to support with finding the right financing and also connecting with the municipality, finding sites and so on. We also work with the Forest Business Accelerator, which is driven by BizMaker, and where we are a partner. And it's an accelerator program for small and medium enterprises within the forest industry. We're also heavily linked into the regional universities, Umeå, Mid Sweden, and the Swedish Agriculture University. But also we work with a lot of other universities as well, as like KTH and Chalmers and across Europe. So with that, I want to just finish my presentation and say thank you for your attention. And I'll give the word back to Karin.
We have a question. As you're talking now about numbers with the project, etc., and now you're talking about your group and RISE locally.
Yep.
National RISE has higher numbers, I guess.
Yes,
Yes.
I would definitely assume so. So these numbers are specifically for the kind of cluster project that we are running.
Yes.
So yes, and only within the last couple of years.
Yeah.
So we are definitely an even stronger global presence, I would
Absolutely.
say. Yeah.
Thank you. And also we have a question from the line. What is your core focus within bioeconomy development?
So we come from the forest industry, so we have a core strength within developing processes for converting forest side streams, forest residues into new circular bio-based products. But those technologies is often applied to other biomasses as well, as agricultural biomasses, marine biomasses. So we can really work on any kind of organic source with the technologies that we work with. So, yeah.
Thank you. I would like to thank you for participating, and my colleagues and Björn Alriksson, Claes Engström, and David Blomberg Saiton. We are obviously we are happy to collaborate in any initiatives towards the global goals, UN's global goals. And with that, thank you, Sweden Innovation Days, for letting us having this space.